Hi everyone, this is Michael from h2x. In this video, I'm going to show how h2x fits into the RIBA plan of work. Now, every construction project moves through this plan, whether the people involved know it or not. It essentially is 8 stages, starting from the initial idea of the building to monitoring that building once it's in use or once it's been handed over. As engineers, we don't really touch all of these stages equally. Design work really happens in the middle stages, 2 through 4, concept, coordination, and technical design. So in this video, I'll walk you through these 3 stages in order. For each one, I'll show you what the stage actually asks from us and how h2x will help you deliver that. Now, stages 3 to 4 are concept, design, spatial coordination, and technical design. Let's start with concept design. This stage, the architecture is still taking shape. What we need isn't a fully finished design, it's an outline strategy. Roughly what system do we require, roughly what size does that system need to be, and how much space is it going to need. So that's risers, plants, service routes. If we get this wrong, it'll come back to bite us later. So the goal is a fast, defensible first pass without spending days on it. Now, if we move over to h2x, you can see here that I've already uploaded a simple architect's floor plan with indications of what each space is going to be used for. Now, if we switch over to design mode, h2x will enable us to model different flow systems on top of this plan to pick up things like pipe lengths and service positions horizontally in the first instance. Now, if we connect our equipment here, you can see that we can add a cold water tank, which will be sized based off a diversified peak flow rate requirement based on the system connected downstream. And all of that's calculated automatically. Also on the equipment menu, we can select a booster pump, stamp it down, and a piece of hot water plant. On this first pass, h2x will allow us to make specifications to what shape or size that particular component might be. So for my hot water cylinder, I'm going to say it's going to be at least a 900 mm diameter. And on the inlets, I just want to turn off the gas inlet as well. Now to use the pipework tools, they're just up at the top here. We can draw our main pipe from each of our different pieces of connected equipment, and we can bring those up to different heights if needed. You can see that they're initially at 100 mil above the floor, but we can bring that up to 2.8 meters. Now to connect up our hot water flow and return, we can either switch over to hot water up at the top here, or we can use our multi-pipe tool to pick them up directly from the hot water nodes from our hot water plan. We can line those up with the cold water and again bring them up to the height of 2.9 meters from there. And then we can drag that over to bring those together like so. Now that we have our 3 main pipe services, we can run those through the building at that height of 2.9 meters. I'll run that just past the offices here. And I'll branch it off and run it up towards the toilet and into the kitchen area as well. Now, to set the load on each of these different branches, we can use our different node drop downs off to the right here. But before we do that, we're just going to connect up our hot water return pipe and add our balancing valve for each of those different routes. You can see that that will now separate our services into cold water flow, and hot water return, visually displayed by the different colours, which can be controlled and edited by yourself in the system settings. Now to set the load requirements, we can go to the node drop down here, and I can review the different nodes that I've set up for the different areas of this building. You can see I've got a toilets node, which has 10 WCs and 10 basins assigned to it. I've also got T-point nodes for each of my offices, assigning a kitchen sink and a dishwasher to each of those different room types. The associated loading units for each of those different fixtures marked down on those nodes will be diversified based on the peak flow rate diversification method in the system settings. And to assign the load, we just need to go to the node drop-down, select the toilets, for example, go to the node drop-down, select the kitchen sink, dishwasher, and then basin. We'll click on and delete that. And then we can go down to the node drop-down, use our T points, and stamp those down as well. Now at this point, we're ready to run our results and get our initial pipe sizes based on our max velocity, pipe material setting, and max pressure drop settings. So we can choose a copper pipe, max velocity of 1.5 meters per second, and a max pressure drop rate of 0.35 kPa per meter. Now, if we run the results, h2x is going to tell us what our required pipe sizes are for each element of that system. You can see that we've got a calculated pipe size, calculated pressure drop rate, and a calculated velocity. And we're also able to highlight our index node path, which is our worst case pressure loss route for each of the different elements on that route. So that's the fittings, the pipes, any associated valves or nodes. Because we have that information, h2x has calculated our required booster pump duty. Off to the left-hand side here, you can see 0.54 litres per second at 279 kPa. And that is how we would get our initial pipe and plant sizes at stage 2. Okay, moving on to stage 3, this is the spatial coordination. This is where the design gets real. Architecture and structural services all have to fit in the same building. What's needed here is coordination. So what we can do is we can switch out our plan in h2x, switch over to floor plan. We can unlock that plan and we can move our revision A for our ground floor with a few more service details on there to enable us to do a more detailed layout for our system design. Lock that into place. Now, if we go over to our right here, you can see that we've got a detailed layout with different fixture locations. Now, I'm going to show you how to put this together on these two T points here. So if we go to design mode, we can do a right click and drag to delete those elements there. And we can use multi-pipe again to bring our pipe layouts over and into our T point locations. Now, if we want to drop those down to the height of the sink, so let's say it's 1 meter above the floor, we can run one set of pipes that way and one set of pipes off to the left as well, or off to the right, that is. Now, if we copy and paste that across, Control C, Control V, can bring that over and connect it up over here. But in this instance, we want to flip the hot water connection over to the right-hand side. Now, if we go over to the fixture drop-down, we can select our kitchen sinks, place them down where they're located on the plan. And we can also select our dishwashers off the drop-down as well. So yeah, let's go and get those dishwashers. Stamp those down on the plan. Now, to connect these up, we can either do individual branch connections like so, or we can click on each element holding control and hit auto connect like that. To add the detailed elements such as valves, you can select them off the drop down menu at the top here, or you can just type in A on your keyboard and use our shortcuts to add the valves in a way like that. Now, if you do have a more detailed setup put together already, or you've spent time on a particular setup, you can copy and paste that entire element and connect that anywhere on the branch, assuming you have the cold water and the hot water to connect to. You can see how it just snaps on. A better example of that would be using the full layout that I have off to my right here. So that's all of my toilets, kitchen sink, dishwasher, basin, all set up and connected there. So what I'll do is I'll deselect or delete the elements off to the side here. Select this. And line that up with the fixtures shown on the plan. You can see that it's not connected by it showing up transparent. Now to connect that up, we just need to select this with a multi-pipe tool, bring that over to our bottom point here, and individually drag each point over to the correct reticulation point there. You'll know that they're connected because the system will fully light up and you'll get a flow direction on each pipe and it'll all appear as it should. You can also add in a ventilation system design or other flow systems alongside the water system to allow for inter-system coordination during stage 3 as well. So for example, I've drawn out this duct system design, which follows the exact same process as laying out the water system pipes. This time we're just dealing with peak flow rates at each of the diffusers to determine each duct length requirement. Now, in this instance, again, we can get the pressure losses, velocities, index node paths, and get the fan duties for each of the different components on there. But the good thing about h2x is you can show this on a 3 model within the platform to check for things like clashes at this stage of design. So you can see here I've worked the pipework around this duct as to not cause a clash. Perfect. Now this brings us into stage 4, which is the technical design. Here, ideally, this is where the design starts to settle. What's needed is a full package for construction. Calculations someone can check, drawings someone can build from, and quantities someone can price. It all has to be coordinated and it all has to agree with itself. Now, H2X can help at the technical design stage in the following ways. We can provide a fully detailed system design report from our list of exports here, and we can also show a full bill of materials. If we go ahead and open up the design report, we can show for our water calculations what the requirements for each individual pipe length are in terms of flow rates, velocities, pressure drops, etc. We can do that for our fixtures, our fittings, our valves, and we can order all of this in the index circuits and index node paths to validate our pump selection or our plant selection. Now, the bill of materials will take all of the information that we already have in terms of pipe lengths, number of fittings, valves, etc., and it will place that onto a fully formatted bill of materials where you can see the total number of fixtures required, total number of pipe lengths, total number of connected fittings or valves, and this can be implemented with your own rates using this master rates page here. So you can say what you might charge per meter of copper pipe at a certain size, and that'll feed into the rest of the document. Now, when it comes into the drawing categories, we can export a drawing set from h2x that could either be used as a stage 3 design sent off to someone to see the coordination of things like the ductwork and the pipework together with your chosen filters off to the right hand side here. You can also put your own standard logos, company details, notations on this layout and have that taken directly from the software at a set paper size and scale. We also have our own dedicated AutoCAD and Revit plugins. So if we had this working drawing within AutoCAD, we would just need to download a JSON file from h2x itself. We could then type in h2x import within AutoCAD. And then we could map our specific flow systems to our specific layers in AutoCAD. Same thing for valves, same thing for fixtures, plant, risers, etc. And you also have the ability to map your specific blocks to these elements as well. Now, if I hit import, h2x is going to generate all of those different DWGs for me and save them in a save file location on my own computer. I'd then be able to either open up that file separately or XREF that design onto my working drawing. If I go and XREF my new plan in, I can go to my downloads take out my RIBA stages of work design here, and I could then specify on screen my base point that was used initially to add the floor plans in h2x. And you can see if I double click onto these elements here, they've been brought in as an XREF, but I'll be able to essentially assess which layers they go onto. It is a little bit dark for you guys to see that at the moment. Let's just go back. There we go. But you can see that they've gone onto their own respective layers and they've picked up those layer properties as per the DWT that you're currently using. Now, if we switch over to Revit, the Revit process is done in a very similar way. This full design has been generated by Revit based on the project that we've done in h2x, but the process involves, again, using our Revit plugin, selecting the project that we've worked on within h2x itself, aligning that to a base point that we can assign to a similar position within Revit, and assigning each of the different flow systems, pipe materials, levels, valves to their associated Revit flow systems, Revit pipe materials, Revit families. Now that's a taste of how h2x can assist at the different RIBA design stages. Now, if you think that this video was useful, or if you'd like to see this applied to one of your projects, feel free to reach out to us on the link on the description of this video. Thanks very much for watching, and I'll catch you later.